Okay, so before I actually start talking, I want to sort of say thank you to Sam, Tavis, Charles, Bear, and Saba for organizing this, and Hootsuite again for the space. So, you know, give them a round of applause. And I very much encourage questions while I'm speaking. So feel free to pause me, try to get my attention. Anything you want to ask me, it's all good. So I'm going to tell you a little bit about a project that I did, mostly summer, fall, and a little bit into now. Mostly on my own with a little bit of help with some people who I'll mention. And this is currently not live, so be careful with photos and things like that. It's in staging right now, but it's not actually live on the site. So if you want to ask questions about that, feel free to. So you're kind of getting a sneak peek on some stuff. So just to sort of give you my background, I think most people here know me, but just in case, I came about data science from kind of a twisted path. I started out as a string theorist, and I really started out as a string theorist. So I did 5 years of a PhD and about 6 years postdocing before I saw the light of work-life balance and actually doing fun things with my life and not moving every 2 years. But in case you ever want like a bedtime reading or something, all my papers are available on the web. Feel free. They're really exciting. And I'm currently the senior data scientist at POF. I think everyone here knows about Plenty of Fish, but just in case you don't, we're the world's largest online dating site, at least for free users. Daily we get about 3.3 million to 3.5 million unique daily visits. We currently have about 80 million registered users. It started out, as every startup does, in somebody's apartment or basement with one guy running it. It took off. Now we've got about 70 people, and we are hiring. We've got web and native apps for iPhone, iPad, and Android. Currently the research team, we're not going to count Nissan anymore because he's no longer on the research team. So it's 4 people, including myself. I've got a PhD in physics. The other 3 have PhDs in things like machine learning, computer vision, computer science. So if you guys are interested in that kind of stuff in the team, please feel free to ask me after the talk. I'm more than happy to chat about it. So the basic outline, first, like I would wish a lot of people would do, I'm going to say why I did this. So why interest-based matching in search. And then I'm going to tell you a little bit about what the actual problem is. So how do I do it? How do I set it up? A lot of the sort of difficulties with developing this sort of system. Then I'm going to tell you the solution to spoil it, which is I use topic modeling and something called Latent Dirichlet Allocation, which I'll go into. I'll give you sort of a quick couple examples and a cartoon version of what LDA is. Full LDA is probably about a week's worth of summer school lectures. I could probably give an entire hour talk on just the Dirichlet distribution. So I will sort of highlight it. If you're really interested in the gory details, let's talk after. Because it's about, I actually redirected it for myself last week. It's about 15 pages of calculus and algebra and stuff like that. So I just can't do it in real time. And then most of it I'll focus on how I'm actually using it on the site, on real users. And I'll give a bunch of examples. So feel free to ask me if you want. Okay, so why am I doing this? So I'll give you sort of the corporate version of why I'm doing this, and then I'll tell you why I started the project. So we get people that write in all the time. This is an example of a user mail. I've taken out just enough of it so that you can't identify who the person is. So it says, you know, could you please return, we used to have what's called keyword interest searching, where you could just literally type in like, you know, biking, and everyone who wrote biking on their profile you would see. Because basically always finding in all the matches we're showing this person was people who go to the gym, and he doesn't care about that, and he can't find anyone that he is really interested in. The other thing, which has to do more with actual like positioning in the marketplace, so Facebook did graph search. So here, who here knows what, like, has tried graph search on Facebook? Someone has. You type in friends of friends who are do this or that kind of thing. So one of the things that Facebook was hoping to do with graph search was to sort of enter a version of dating. So you could say, you know, show me female friends of my friends who are interested in skiing. The problem with the way Facebook did it is it's, again, very keyword-centric when you query. So, for example, if you type in coffee, it won't pick up on people that name Starbucks or, well, not Starbucks, but since we're in Vancouver, every hipster coffee shop knows man, right? It will not name Revolver and Timber Train and Milano, because we're at Hootsuite. It won't pick up on those things. That said, if a company with a user base the size of Facebook is trying to move into dating, anyone that's in the online dating world really needs to take that seriously because Facebook doesn't play around with this stuff, right? They have billions of users. They have, I don't know, hundreds of thousands of people working for them. God knows how much capital. I mean, anyone that can spend $19 billion on a texting app certainly has enough capital to, compete in the dating world. So that's really important to sort of position ourselves. Now, not on the slide, one of the reasons I did this, one, I had some downtime in between projects. Two, someone told me this was impossible, which is the quickest way to get me to do something. And also at the time, I was single. My girlfriend's not here, so I can say I was single at the time. I'm not right now. And I was actually using the site and a couple other ones, and it was really hard for me to sort of filter through my matches and say, like, find girls who had a lot of things in common with me. And I'd have to look through 100 profiles and be like, I kind of like her, but not this, and so on. So it sort of had personal motivation for me as well. So the basic idea of the problem is we let people write their interests on their profile. So we have the normal profile description that says, all about me, and then we have a separate box that's, list the things you're interested in. And right now the entry for that is literally comma-separated free text. Just say, skiing, comma, cycling, comma, coffee, comma, whatever, and you can type in anything you want in any language you want, and that's the kind of data that I have to work with. Now, you'd like to be able to use this for matching and search, but you want something more sophisticated than keyword matching, because keyword matching is easy, that's quick, right? Like, you don't need a data scientist to make crap. You need someone to make crap. Which is not an easy thing to do, by the way, but not what I work on. So, okay, let's run through the sort of challenges with building this thing from easiest to sort of hardest. So, I don't know if anyone's ever been on an online dating site or a social media site. Not everyone can pass a spelling test. So people misspell things quite a bit. In fact, we'll see some examples later on. I think my top match actually misspells a couple words because Bureau pointed it out earlier. Also, people use synonyms for things, right? So think of all the ways you can say you're interested in biking, right? You can say biking, cycling, bicycling, road biking, mountain biking, God knows how many other fixies, all that kind of stuff you can say you're interested in, and they really all map to the same thing. Beyond that, you also have similar interests, like, okay, I know there's some people that are into skiing who are like, I can't stand snowboarders and vice versa. But for the majority of people, if you're going to be like, I want someone that I can go to Whistler with for a weekend, if they snowboard and you ski, that's probably okay. And, that sounds really simple when I say it like that right now. And I can be like, well, somebody who likes Game of Thrones and somebody else who likes, like, The Walking Dead or something like that match up really well. But as soon as I start trying to do this on 10 plus million users, which is the US and Canada who are currently active in the last month or so, that's kind of tricky to do to eyeball, right? To literally read through 11 million profiles and say, okay, these things should go together, these things should go together, but these things shouldn't. The other thing is that, no person is any one thing, right? So, yeah, you could be into skiing, but like, I wouldn't define myself entirely by being interested in skiing. So what you really want is something that kind of balances all of those things, right? So if somebody lists, for example, here, like climbing, hiking, and skiing, you'd say they're into outdoor sports. But they could also put in craft beer, cooking, coffee, playing the guitar, whatever it is, and that adds to their personality. You want to be able to find a match for them based on all of those things. So those are sort of the initial problems you have to deal with. So just to show you how this kind of works, this is my actual, if you go to my profile, I think this is what's currently on there. I change it up every once in a while to play with it. So I'm interested, so skiing, cycling, climbing, a bunch of really nerdy things, gaming, Doctor Who. If people, please God, tell me you know who Joss Whedon is. Fantasy novels, surfing, Veronica Mars, which is an awesome TV show if you haven't seen it. Nerdy everything. Battlestar Galactica, meditation and psychology I'm interested in. I play guitar. I like graphic novels. I refuse to call it Game of Thrones because anyone that's read the books, it's Song of Ice and Fire. Angel, and actually Angel's an interesting one because here I mean the TV show, whereas other people might write Angel to being like because they're religious or something like that. You have to
would you date someone who refuses to call it sci-fi? It has to be science fiction.
Sorry.
Settle down.
String theory, quantum mechanics, and so on. I'm gonna STEM anyway, so what does it matter? So if you guys saw this, how would you describe me? Like, I'm really asking. Just yell at me, like, based on this. What would you describe my personality?
Nerd.
So I heard nerd, geek, and what was the other one? Outdoor? I'm somewhat athletic. I just play multiple horses. So when I'm running through the model that I built, and I did not game this is what actually comes up. So I'm 37.3%, and I'll show how this actually happened. I just want to show it. TV nerds, I'm about 18% gaming and tech nerd. I have a mix of sort of intellectual arts are things like classical music, painting, things like that. Artsy is also like you actually like actively doing it, and a bit into outdoor sports. So I think based on this, to get to this, if you were my friend, I think my friends who are here, it's a pretty reasonable description of me, right? And I did not have to really, once the model was built, do anything beyond run literally that free text through the model to get this. Okay, so how did I do that? So latent Dirichlet allocation. So I have a fancy graph diagram here for those of you who know about graphical Bayesian inference. Here's a graph diagram. For those of you that don't, here's a graph diagram. So the idea behind LDA is it's a generative model. We're basically given a set of documents, which in this case we're going to regard as a bag of words. You're trying to find the latent similarities or topics between them. So in exactly that, given this set of words, I'm trying to get to this, and LDA does that. So what you really do is you observe the words in a corpus of documents, and you want to infer the topic mixtures. It's important to understand, and I'll talk about this, that it's actually what's called a mixture model, which means people can be X% one thing, Y% another thing. They're not like, for example, a k-means clustering, where everyone is, cluster 1 or cluster 2 or cluster 3 and so on. So the idea is you're handed a set of documents. So in our case, that's going to be the interest on users' profiles. You take them as a bag of words. So what I mean by that is I don't care about order, right? It's just all a bag of words. And in this case, I'm going to work with unigrams, so just single words at a time. A lot of people ask me about why don't you use, for example, like if I write string theory to regard that as a bigram and so on. It's a good question. There's not a great, solid answer. For me, what happened is when I started looking at expanding that out, the dimensionality of my space became gigantic and I just couldn't run it on a computer anymore. But there's probably some clever things to do. The other answer is that working with just the bag of words actually worked really well. So it wasn't really necessary to go to the next step. Because if I want to run this in production, speed is important. So the idea is you want to discover the hidden or latent topics among the whole collection of documents. So that's outdoor sports, romantics, and so on. It's a nasty problem in Bayesian graph inference. What I'm going to show is we're going to start with a simpler imaginary model. So like all things Bayesian, it's easier to go the forward direction, understand that, and then spin around the Bayesian computation. So we're going to imagine instead that I give you the model and you want to create a document. That's not the real problem. We'll get to the real problem, but let's just work through this. So you want to create n documents, so 100 documents, however many you want to create. And I tell you that there's 50 topics that you want to create the documents over. And I give you a vocabulary V, which is, in our case, about 300,000 words. So how many here people know what the Dirichlet distribution is? Wow, okay, 3 people. So what the Dirichlet distribution is a probability distribution of probability distributions, which sounds confusing as hell. But what it really means is that if I take one sample from a Dirichlet distribution. So I pull something out of the urn. What I get is a multinomial or categorical distribution, which everybody, that sounds complicated, but you know what that is. That's saying on a page, I have 20 choices of things I can click on. What's the probability that I click on 1, 2, 3, 4? Each of them have a different probability. The first one might be 10%, the second one's 20%, the third one's 5%, and so on. It gives you that probability distribution. So you draw it once, you get 10, 20. The next time you draw it, you get 20, 30, 5, and so on. So for each document, what you do is you choose a topic mixture for the document as a categorical. So you take one draw from a Dirichlet distribution, and that, for example, might tell you that it's 30% topic 1, 70% topic 7. And then let's say you want to generate 10 words. We'll do an example in a minute. For the first word, you're going to basically draw another sample over a distribution over the vocabulary in that topic. So that sounds confusing. We're going to do an example. It'll become clear. So here's the really simple example. Let's imagine we have two topics, topic A, topic B. So each of these have 100,000 words in them. The vocabulary is fixed. So every word is in topic A, every word is in topic B. It's just that they occur with different probabilities in each topic. So topic A is 30% baseball, 15% football, 10% soccer, a bunch of other things, and 0.0001% puppies. Topic B, on the other hand, is 20% puppies, 20% kittens, 10% cute, 5% hamster, and way at the bottom, it's baseball. So, like, how would you describe sort of topic A?
Sports.
Yeah, and topic B is pets, right? So,
are you using, is it you that label this?
yeah, so the only thing LDA doesn't give you, which I'll show in a bit, is it gives you topic A and topic B. It doesn't tell you what to call topic A, right? So the one thing I had to do to generate that pie chart before was pick a name for the topic, which for us is actually important because I found when I was shopping this around to people in the office and I created their charts, some people were not happy with what categories they ended up in. I had one that I named after the Jersey Shore called GTL, or Gin Tan Laundry, and the people that ended up in that category were not happy. So it's an important sort of public relations thing to pick the names of these things carefully. So let's generate 2 sentences of 4 words. So the first sentence, I sample from the Dirichlet distribution. It tells me it's 80% topic A, 20% topic B. So then I'm going to go to the first word. So what I do is I go back to topic A, and I say, give me a word from topic A. So I basically flip like a however many sided coin or I roll a die. And it happens to come up soccer, because that had a high probability of coming up that word. The second time I do it, I get topic B. I go back to topic B, I flip another coin, and it says kittens. So I go soccer, kittens, repeat 2 more times. In this case, I got soccer, kittens, baseball, football. That's the sentence. That's the document. The second one, I sample. This one ends up being 90% topic B, 10% topic A. The process is pretty much the same. And in this case, notice I ended up with cute, puppies, kitten, hamster. Just because it had a 10% probability of topic A doesn't mean that I'm going to select topic A. Also, just because even if it came up topic A doesn't mean that I'm going to necessarily get one of the top 5 words in topic A. I might get a word way the hell down. And if you have 10 million documents, that will happen occasionally, because you have like a 0.01% probability of getting that. So the whole point of this is that it's probabilistic and it's not deterministic. Now, full LDA is the reverse problem. I hand you the documents, figure out everything else. So that's why it takes 15 to 20 pages of math. So in reality, it's not as bad as it sounds. What you do is you write down the Bayesian equation, like you write down a Bayesian probability distribution, you move the right things over to the right-hand side of the denominator. Where it gets tricky is that the denominator ends up being a sort of large sum and an integral, and it doesn't separate. So like all things, people that are done physics and things like that, you need to approximate that integral. And a lot of the really nasty stuff, which I've shown like, I don't know, step 37 of 105 here, is approximating that integral. And all of this graph stuff that I showed before is basically a shorthand for which things depend on what other things. So the point is we can write down the total probability distribution. You can separate out a lot of terms. So for example, theta only depends on alpha, it doesn't depend on the beta part of the distribution. So in this case, this is representing a Dirichlet, this is the topic mixture probability distribution, so you don't have to worry about this part for that thing, and you kind of work through the equations. So it looks nasty, but really at the end of the day, you're doing relatively standard approximation techniques. There are things like variational methods, expectation maximization. In this case, I use something called collapse give sampling, which does a Markov chain Monte Carlo. Basically, you keep sampling lots and lots of times, and at the end of it, you basically say, well, the number of times this result came up divided by the number of times this other result came up is the total probability of that thing coming up. That's your probability distribution. If you really want to know this, please feel free to discuss it after the talk. I just can't do it in real time. So how I actually do this is, this is real production stuff now. So I first need to build a model before I can run it on users. So what I do is I grab a set of user interests. So in this case, I restricted myself to North America, so Canada and the United States. There's nothing preventing you from building this model in other languages, but you definitely don't want to like throw German in with English because it's just going to get nonsensical. So you have to separate out. The reason I didn't include the UK is a lot of their interests and spellings and things like that are just slightly off enough that it's probably best to build its own model. But that was just a decision I made. And in this case, I think I restricted to, they had to have like logged in the last 2 weeks or something, and that came out to be about 4 to 6 million people depending on the run. So you're left with several thousand users. The vocabulary ends up being basically every word they've ever used on their profiles or on their interests. That ended up being several 100,000. The sort of decision you have to make is how many topics do you include in the model. So that's one of the inputs. So there's no hard and fast rule, and because this is what's called unsupervised learning, you're not building a classifier, so I don't have anything to judge it against. It's not like I can say, you know, this model was 93% accurate, this one was 85% accurate, so this one's better. In this case, it really was a question of eyeballing. You know, I create the model, I build some things, and I'd sort of look at how things were grouping together and what, you know, I as a human being would see as the most natural stuff. The basic idea of the way it works is, so the more topics you pick, I call it a finer seed. So for example, if I pick like 1,000 topics, it's very likely that skiing and snowboarding will be high in very separate topics. If I pick less topics, then skiing and snowboarding will probably start occurring in topics together. And if I pick even fewer topics, then skiing and snowboarding might end up going with like baseball, basketball, and so on. Like it won't separate out outdoor sports from team sports from a bunch of other things. And it's really a question of, you know, what are you trying to do? So if I want to get people sort of like really broad matches, then I might build a model with only 10 or 15 topics. If I want really hyper-specific, I might go to 100 or 200. In this case, I think I ended up settling on 30 just by kind of playing around, but that's by no means like fixed. Various times I sort of tried different models. Then the other thing is you run LDA with various parameters and various approximation schemes. So I didn't just pick collapse give sampling. I tried collapsed, I tried VM, I tried a few other things. The collapse give sampling tended to give sort of the best results. But for other applications, VM might be the thing you want to go to. One thing about give sampling is because you're running it probabilistically, you're running a Markov chain, the results for users can change every time you run it. Especially ones who are kind of thresholding between different topics. VM will be deterministic, and that may or may not be important for your application. So okay, this is actually what it spit out. There are 30 topics in this model. I highlighted a few. So, like Charles mentioned, I don't get the name for the topic, right? But this is the actual words. This table actually extends down to about 250,000, but obviously I'm only showing the first 10 or 15 words. So here's topic 10. Golf, hockey, tennis, so I STEM, so that's why it's tenny, not tennis. Soccer, volleyball, snowboarding, skateboarding, so on. So what would you guys call topic 10? Okay. Topic 13 was nature, science, history, politics, philosophy, physics, technology, astronomy, so... Yeah, so I think I call this intellectuals or something like that. Then you have like ski, boat, snowboard, water, kayak, dive, mountain, surf. So I kind of went with outdoor sports for that. This one's kind of fun. Drive, cuddle, long is for long walks on the beach. Talk, night, listen, romantic, country. There's another one that I didn't show that had like thunderstorms really high up in the thing, or candlelight was pretty high. 27, I guess you guys, please God, tell me you can get this one. Video, anime, books, computers, comics, technology, star, electron, sci-fi, not science fiction, electron, internet, Xbox, paintball, Netflix, fantasy, video games, so, yeah. Topic 30 actually threw me for the first time I saw it, because I saw Big and I was like, what the hell is that? Yeah, it's Big Bang Theory. So Big Bang Theory, break is for Breaking Bad. Black, I think, is for either Orphan Black, or there's another show. Yeah, Orange is the New Black. Thank you, that's the other one. Dexter, Anarchy, Mothers for How I Met Your Mother, South is for South Park, so TV nerds. So this is what we ended up actually calling them. So you guys were close on this one, but because it had golf, hockey, and tennis up there, I went with conventional sports. Intellectuals, outdoors. So because there was also the thunderstorms people, this one became casual travel romantics. I can't remember the other one was. Gaming, tech nerds, and TV nerds. So how clever is this? How does it actually work? So one of the important things is that I don't pick those groupings. So if everybody that wrote snowboarding also wrote puppies on their profile, then it would group snowboarding and puppies together. That doesn't actually happen, but the point is that I'm not deciding ahead of time that based on my opinion that these things should go together, because I'm one person and I have a very biased sort of opinion of what goes together. So it's important to sort of avoid that. The other thing is that any word, whether it's misspelled or slang or anything like that, enters the vocabulary. So you don't have to worry about the fact that like people can't spell bicycle, people cannot spell bicycle. I don't understand why, but they can't. People, including myself, cannot spell rhythm, by the way. I always misspell that. And so because anything that you can do enters, you can start, and I threw it at this. So I took one of the models, and I just started throwing everything at it. So my friend Olga started giving me all kinds of obscure artists and philosophers, because she's a graphic designer and a UX person. And it kept, for the most part, 80-90% of the time, getting them as intellectual or artist or something like that. If you write Stormcrow Tavern, who here knows what Stormcrow Tavern is? Yeah, it throws you into gaming sci-fi nerd, and it throws you with someone who lists lightsabers as a topic, and it just figures it out. So even though I'm running on every user in North America, it knows what Stormcrow Tavern is in Vancouver. So because it's determined organically, it works really, really well. So let's take an example of that. So look at the top left. So this person wrote Bulls, Bears, Cubs, Yankees, running, bodybuilding, MMA or mixed martial arts, hip hop, and live music. So if I was eyeballing this, I would have said sports, right? Because he lists a bunch of sport teams. But it turns out that those specific teams, and especially the fact that they're in major markets, is actually much more like highly occurring in sort of an urbanite category. It occurs with things that people list, like going to museums, going to live shows, a lot of things you associate with people living in a major city. So he ends up in urbanites and not in sports. The other person, on the other hand, so he lists some of those things and he has some urbanites, but because he actually lists playing those sports, he's much more tilted to the sports category. And notice also that they both have alternative fitness. It knows that MMA is the same thing as mixed martial arts. And it will figure out that kickboxing is the same and they all go together, and so on. Also because everything you list puts you a little bit in each bucket, but eventually at the end of the day when I normalize it, it only picks the highest ones. So remember on my profile I wrote Angel, but because I wrote a bunch of other sort of nerdy TV shows, it tilted me way more towards the TV nerd, whereas if you write like Angel and a bunch of religious things and volunteering and church work and so on, it sort of tilts you way more towards like a family values religious sort of category. So it does actually, in most cases, pick up on the context using the other words in the thing. It's of course not perfect, but it does a pretty good job. Okay, so how do I actually use this on real users? So I take a topic model, And I do a bunch of post-processing. So what you'll find is everyone has a little bit of drop in every bucket, but someone that's 0.00001% in topic 5, it's not useful for that for matching. So what I basically do is I say below a certain threshold, set all those equal to 0, and then I basically renormalize the vector. The two obvious ways are I can make it a unit vector, or I can make sure that basically the probabilities all sum to 1. I went for the latter because it worked better, but either one is fine. And I run and update this on basically every Canadian and US user on the site in real time. So how do I do it? So the R side, so I do this in R, so because this is the R meetup as well. So the majority of the heavy lifting is actually done in R. So for people that say, oh, you can't run R in production, they're just wrong. So packages I used. So RDBC, which is R's sort of main package for connecting to a database, at least for SQL type databases. Actually anything with an ODBC driver it'll connect to. Topic models, TM, which is text mining, 4H, do parallel, and a bunch of custom stuff that I had to write myself. So RDBC, we're a .NET shop, so we use SQL Server, so I use that to basically rewrite data out of SQL Server. TM is the basic sort of like pre-processing step, so take in the raw text, do things like eliminate punctuation, lowercase, get rid of what's called stop words. So a stop word is like the words that everybody uses, but have no actual meaning. Well, not meaning, but meaning in this context, right? Someone writing A doesn't give me an interest to match off of. And then I use topic models, which is basically actually a wrapper for a bunch of open source C and C++ code to actually run the thing. And then because I'm running on 10 million people, I oftentimes have to parallelize a lot of stuff. So I use 4H and do parallel for the pre-processing and posterior calculations in parallel. So a lot of the preparation and stuff. The only unfortunate thing is that the actual LDA model itself, because it needs to work on the entire corpus at once, cannot be parallelized. So you better make sure you're running on something where it can fit. So yeah, like, you know, I couldn't run this on 50 million people on our current architecture, but I can run it on 5. And 5 million gives a pretty good thing. So that's just to build a model, and then I can run that model on every user. On the SQL side, so...
Sorry, why did you choose R? That's pretty good. Do it or not?
No, we use R as our basic. So the question was, why did I choose R? R is our basic sort of tool of choice for data science and pop. So most people go either R or Python. We're R, so my default is to work with something in R, and if it doesn't work, then look at it in Python. Other people will go the reverse. I think you can do this in Python just as well. I also happen to know R better than Python, so why not work with the thing you know? The actual R code for LDA is, when I tested it, was basically just as fast as just downloading the open source C and modifying that and running it. So you're not really gaining anything. And I can imagine like the Python implementation, which wraps the same code, is going to be significantly faster. But yeah, you can do this in your favorite language. I did R because that's what we use. We store all the vectors, so, you know, profile ID or user ID, all their sort of, you know, they're 20% in this topic, 10% in that topic. That's just stored in a table. The actual similarity scoring and matching, which I'll get to, those are really simple functions in SQL that I just wrote. So basically what happens is when new users create profiles or existing users update their profiles, they get inserted with a trigger into a queue table, and then there's a continuously looping R process running on a server with a bash script, and that basically consumes that table, and then, you know, writes up to SQL Server and takes care of all the logging. So there's a bunch of store procs that, for example, make sure things aren't colliding, that you're grabbing the right set of users and logging for that. That basically is running right now. It's been up live for about 10 weeks in staging on every single North American user on the site. And basically at this point, if you change your profile, I can show you new matches in about 2 seconds. So I'd like to get it faster, but it's still pretty good at that scale. Okay, matching and search. So you can do distance, or you can do similarity. I've done both, actually both are implemented, and most of the time I kind of randomize over it. So distance here is I have a vector over here, I have a vector over here, and I can compute sort of the Euclidean distance among that. You can weight this, which is basically putting it on a curved manifold if you want to like weight one topic over the other or something like that. Totally doable. You can also do things like cosine similarity and so on. So basically, any metric that takes in two vectors and returns a real number is a good thing, right? And then it's just a question of which one's giving you matches you like. You also sometimes don't want to exactly match on your own interests. So maybe I want to allow you to search. Maybe you want users similar to the ones you're doing. We'll sort of go through that. Okay, so here's my interests again. This is how it actually works. I should mention, I talked about stop words. There's also interest, for example, like movies, that every single person writes as an interest. Everyone likes movies and music. You're not a unique snowflake. So that also doesn't really give you a lot of information. So one of the pre-processing steps that I do besides stemming is something called TF-IDF, or turn frequency inverse document frequency. And what that basically does is it says words that nearly everybody use, just throw out of your vocabulary. And you can play around with that threshold of, it has to be used X% of the time, and so on, to throw it out. And the idea there is that if every single person says they like movies, then matching people who like movies together gets you nothing, right? So you're just trying to isolate the most important words. Okay, so here's my interest again. I'm sure you guys all forgot, because...
Something, when you're learning your topics, are you considering other factors like gender or age or location, like categorizing the user based on these factors, and then run a topic model, or somehow do more sophisticated topic models that consider these factors?
Okay, so the question was, when I'm building out the model, do I think of, say, using things like gender or age or other attributes that I definitely have access to?
Spelling ability.
Yeah. So to build the model, I don't. To match and search, I do. There are several reasons for that. One is if I build a model specific to each individual thing, like let's say 25 to 27-year-old women in a certain location, then if somebody moves or when they grow older, then I have to keep track of they were in the 28 to 29 model, but now they should be in the 30 model, and I have to update that on the fly and log all of that, so it becomes quite complicated. I also, when you start doing that, my worry is that you're stratifying a lot of the sort of user base, and then it becomes a much more complicated problem because if I'm matching people that were learned off different models, it's no longer a simple similarity score. I need some way of classifying that, topic 1 in model A is a really good match for topic 312 in model B, but not 37, right? Because the topics won't line up. And so for matching, then it becomes really almost an intractable problem. So I actually started with that. I built separate models for men and women, and there was nothing to learn off of.
But do you need to learn a new model when you're considering a new user?
No. So the point of this is I build a model, and then as long as the words they're using are, at least some percentage of the words that they use are in this model, then it goes through. So Tavis is telling me to keep going. So
No, I'm trying to repeat the question.
Sorry. Repeat the question. The question was...
I know that you don't need to learn the model again. My point is that when the user moves to a new location, you don't need to learn the model again, so there's no problem.
Well, I don't need to learn the model again, but I mean, in terms of just overhead on, keeping track of everything, I need then, something that sits in the database that says, when this person moves, I have to update their vector, and that has to all be tracked.
Yeah.
Right, so that's a lot of...
I thought you were going to get more meaningful topics if you, not maybe all attributes, but some attributes like location. Maybe word occurrences in certain location infer different topic than when you collapse everything together.
So the answer is yes, probably. And certainly when I separated out by gender, I got that, but then for actually building it for matching and search, I hit a dead end, because then it's I have to match this model to that model, I don't know what goes with what. because I don't have any data, like there's no classification data. So for another application, for example, if I wanted to profile users for something like advertising, then what you're talking about is probably one of the ways to go. But for matching in search, because you want to be matching off the same model, it doesn't quite work.
It's just a follow-up question to the first question. Actually, I had this question at the beginning, why you choose LDA instead of other type of models. For me, like hierarchical Dirichlet process or HTP may suit your problem better. Follow up with the first question, if you're modeling the topics using hierarchical Dirichlet process, you can divide your users into several demographic groups. You can model them separately using groups, and the topics modeled by HTTP can be shared across different groups. Then you won't have a problem in searching and matching because the topics are shared. And another advantage of HTTP is HTTP can handle the number of topics automatically, as I mentioned before. LDA cannot do that.
So one of the answers is I kind of played around with that, and I was seeing.
Repeat.
Oh, well, he had the mic.
Oh, yeah.
So I played around a little bit with hierarchical models, as well as like 10 other things that I haven't talked about here. Hierarchical gave me a bit more of a hit computationally, and I wasn't seeing a tremendous amount of lift there. That said, it's something that I would like to revisit at some point. This kind of got me to where I needed to go. As far as the number of topics, so there's a lot of like literature in hierarchical and non-hierarchical about like, you know, given a corpus of this size or this many users, you should do something like log or square root or whatever it is. I played around with those and didn't really see very compelling results with that. To give you a list of other things I tried straight up clustering methods, I tried hierarchical clustering methods, I tried LSA, fuzzy LSA, a mixture model based on that, NMF, and 2 or 3 other things that I'm thinking of. So there was a lot of other things that I tried. Hierarchical, I played around with a touch. There's also correlated topic models, which can tell you the relation between like topic 1 and topic 7 and how correlated they are. So if you have similar topics, I played around with that. I didn't see a large enough lift to sort of commit to it, but I do actually want to go back there again at some point. Some of it just came down to time. I was the only person doing this, so it came down to that.
So if I really hate Nickelback, am I going to get really sucky matches with this?
Wait, if you write "I hate Nickelback"?
Yeah. So
at the moment, yes.
Yeah.
Yes. So negation. And one of the reasons I focused on interest, I actually tried this in straight up profile text.
Yeah.
Is there's a much lower occurrence of the negation problem in interest. The percentage of people that write "not this" is like less than 1% on the site. So don't write "not Nickelback" for now. But I agree with you because Nickelback sucks. That said, there are ways of handling negation. So, for example, one thing you can do is just add an underscore. So if you wrote "not Nickelback," I would drop the "not," but write it as Nickelback underscore "not" and save that as a token, and then I can do that. It's common in things like sentiment analysis and so on. So there's various ways of handling the negation problem. If more than 1% of people start writing stuff like that, then it might be worth the computational hit. At the moment, no. And also the hope is that if you write like 37 interests that are not this, not this, not this, you're going to get a really bad match. If you write 1, you're probably going to be okay if the other 36 are in the positive category.
So I have a question here. Start with the mic.
Back here.
Yeah. So my question is, I know you talked about stemming and stop words and classification. I was wondering if you thought about using some of the open source technology like Lucene for like stemming, stop words, or Apache. How would I think they do?
So I guess my reasoning would be it takes very little time to stem in R, so why graft Lucene onto this?
How about like classification? I know how would they do quite a lot.
I've not really used Lucene very much, so I can't really answer that, but I guess my sort of MO is if something's working at the speed that I need it at currently, then I'm not going to graft other things onto it. That's not saying you couldn't do it in Lucene. I honestly don't know. But this works at the speed I need it at.
That's fine. Just
yeah. Like all those, like a lot of those stemming and stop word and all that kind of stuff is built into R in the various packages, so it wasn't really necessary to go to that.
So you say that you never rebuild your topic models? Like,
no, that's not true.
Okay.
So I do. For every rebuild, then I have to like regenerate every user, and I do that, and I have processes to set that up. It's an open question, is like, how often should I do that? Not as often as you'd think. Yeah, like if I wait 3 years and the TV shows on Netflix are all totally different, then yes, it's going to get a lot of things wrong. But like in a 2-week period, probably not, right? So what I would do if this goes into full production is I would do like I'd have a like a staging table and then the live table, and I would build the staging table off the new topic model. When it was done, I would just flip it, right? And that would be it, and it would run live. And I do that for other systems as well. When for scam detection, when I rebuild a new scam detection model, I have the live table and the working table. When the working table is done, I just do a quick rename and flip it, and it works fine. Okay, here's my interests again. And this is actually my top batch as of this morning. So, science, politics, psychology, and this is, the matching is all done, it's age, location, appropriate, I don't like smokers, so all that's taken into account. This is actually like a girl live on the site right now. So, I say I'm interested in things like string theory and quantum mechanics, she's interested in science and Neil deGrasse Tyson. It knows what LOTR is. Veronica will hate me if I don't point this out. Snorkeling is misspelled. That is not how you spell snorkeling. It figures that out.
So is Stephen Colbert.
Where is Colbert? Yep, there's a PH there. You are correct.
Question back here.
Sorry, I was just curious, you said that you use every word in the users you use to build your model. I guess I find that in R, when I'm building a corpus, my vocabulary is often limited by the amount of memory it takes to build it up, but you don't find that you have that problem?
It helps if you have a 1/4 terabyte of RAM.
So that's just how you get around it.
Yes, that said, I have actually built things. So one thing you can do when building a corpus like that is you can chunk it, you can shard it, which I actually do. And you can build little bits of the corpus, or for example, the term document matrix, like bit by bit by bit, and then loop through in like C or R bind, depending on how you want to do it, which also can have memory issues, but Plier and some other packages by Hadley does that quite well. Like there's a version of R bind and C bind you want to use in Plier or dplier now that, for example, will handle non-overlapping columns. So it'll actually populate them with zeros correctly and things like that. You won't fail out. And I built that not for this project, but for another one before I had this cluster. And it worked fine. I ran it on millions and millions of, in this case, ad text. I was doing scam detection for ads, and it worked fine. So parallelize there. The only thing you can't parallelize here is the actual LDA run, but all the pre- and post-processing can be parallelized, and is, in this case.
Thank you.
Okay, search.
One more.
Another question?
Yeah, excuse me. Those interests you are mentioning, considering your model importance of the rank of the interests. Suppose you have the science at your top, the first.
No, order does not matter here. And you'll often find with actual user profiles, including my own, I kind of free-streamed it. So I happen to think of physics at the bottom, not because I think physics is less important. So you could certainly do that. That, for example, would be like one of the weightings I'm talking about, either in the matching metric or when you're building out the model. For user interest, because there's no call to action on the site for write your most important interests first, it's not really productive. I can't make the assumption that a given user ranked them in order. If we were going to do that, then I certainly could, right? And I could put weights on those things.
That's when I was thinking you can weight the interest of the given interest based on the order, because first you think the first interest will come the first position, the second like this. You don't think that?
I don't really see any evidence. Like I don't have any evidence of that on the site. Because if I just look at a random user's profile, it's not obvious to me that the thing they wrote first is the most important thing. So I guess to me it's not really the thing I would do in this case. like I said, if we actually had a call to action, so we changed it on the site. So it said, rank your most important interests first, which is a legitimate thing to do. Then I would put in that rating, and it can absolutely be put into this. It's just right now I don't really see it as the right use. Okay, so let's do graph search. So here's a few queries you can actually do with this. So if you search, this is based off my profile, but if I just type in Dota, Skyrim, and League of Legends, here's a couple profiles that show up at the top of the list. So anime, gaming, yoga, dance, animals, riding my bike, anything intellectual, nerdy, biking, board games, video games, and so on. So it actually gets that kind of match. Buffy, Angel, Firefly. Let's do that. So here's a girl, gym, travel, music, Hunger Games, Harry Potter, Zoolander, Wedding Crashers, Game of Thrones, Walking Dead, The Simpsons, Big Bang, How I Met Your Mother, and so on. So again, she's not listing the specific TV shows, but it knows nerdy TV show, you'll probably get along. I kind of also want to mention she has Wookiee Jesus on her profile, which is just awesome. Then let's do the other, let's go completely the other way. Hunting, fishing, camping, aquatic. Anything with a motor, car shows, Chevys, tattoos, shooting guns, apparently is an interest. Trust, sunsets, 4x4 at P&E, which is the amusement park. So that's pretty good. I didn't really know snakes was an interest, but apparently it is. And so on. You'll also find, for example, it's not here, but people that list these things also tend to put things like family and respect, and they kind of go together a lot. So apparently family values and shooting guns is like awesome. And this one's thanks to Agent or Joseph Malone. Everyone look back here, he's the guy with the dog in the back. So I was basically daring people to give me hard queries one day. And he fired back, carrying sensitive MMA and motorcycles. Because who doesn't want that? And here's what it actually gives you. Kawasaki Ninja, which is a sport bike, snowboarding, comedy shows, pampering myself, walks and talks. And then the next girl walks along with H, which is always caring and sensitive. Muay Thai, and is it Muay Thai or Muay Thai or Muay Thai? I don't know. Which actually I think is misspelled, and kickboxing. So it does actually get it. So if anyone ever wanted to find the caring, sensitive MMA motorcycle girl on our site, you can, apparently. The other thing you can do, which is kind of cool, is you can group vectors together. And if I have vectors, I can take average and standard deviations and things like that. So I can, for example, ask, what's the personality of New York City or Vancouver? And things like that. I can find, this goes to your question, who was it who asked about separating things out by gender and stuff like that? So we've done things where, like, how do women in Vancouver of a certain age compare to the generic woman on the site or in other areas and so on? And you can actually see differences there. But it does actually pick up the differences geographically.
So how do they?
Women in Vancouver really like yoga. A lot. So if you're a girl in Vancouver and you write on your profile that you like yoga, Pilates, or any variation of those things, congratulations, you're the same as every girl in Vancouver.
You need a terabyte to find that out.
Yeah. In this case, no, you don't. They also really like a lot of like hipster food stuff. And veganism shows up a lot in there, so surprise.
And the guys?
I forget the guys. Also yoga. Yoga, a bunch of sports. The Canucks is really, like, things are centered around team sports because the Canucks is in there. A lot of hockey stuff. So that all kind of gets picked up. And I'll show you in a second. You can do where's the best place to live. And myself and my team lead, Steve Aldridge, we actually cooked this up for me. Because where should I live? In case they ever kick me out or anything like that. So this is where I should live. So we didn't pick the colors, or he didn't know Republican and Democrat when he picked the colors, but blue is good, red is bad in this area. So I should mention I'm a liberal Jew from New York City, so the fact that New York is one of the top ones, pretty good. Pennsylvania is actually kind of weird. Who here's been to Pennsylvania, any part of Pennsylvania? So most people who've been to Pennsylvania have been to Philly, right? So you think of Philly as a pretty urban place. There are parts of Pennsylvania that are the Bible Belt. If you go into the central part of PA, it is like literally Southern Baptist. Like Baptist is like the #1 religion there. It's like a church every block. So that's why like Pennsylvania, which is here, is kind of all over the place. So it kind of likes it, it kind of doesn't. Florida, it's kind of lukewarm on because that's where Jewish people go to retire, so I'm not old enough yet. And then over here, okay, so good, Pacific Northwest. I live in the Pacific Northwest, so that's good. I used to live in California, and it's basically everywhere that I can surf, ski, or climb, or ride a bike. Well, and that makes sense, and that's why Alaska's here, because Alaska has a lot of things like skiing and surf. Well, you can't actually surf in Alaska, don't believe me, but you can, and that's why that stuff is actually there. So there's lots of other things you can do. So I can, for example, show people those charts or a bar graph. I have one slide left after this. I know you're looking.
Plenty of time.
Okay. I can show you, let's say you send a message to someone, I can show you users similar to that person, which is kind of nice. You keep clicking on the site. I can show you, let's say you're looking at a profile and you're like, well, this person's kind of cool, but they're not really doing it for me. Show me 50 people that are like that person. That's one button click away. I made this. If anyone here, I don't know if girls have this encounter, but I experienced this a lot. I had some female friends that I had a crush on who would be like, oh, if only I could meet a guy like you. And you're like, hi, I'm like me. I call this the I wish I could meet someone like you feature. I don't know if that's a thing for women as well, but it's definitely, I think probably most, especially nerdy guys in this room have experienced this. I can also do, although probably won't go live on the site with this, but I did it for people in the office. I can show you your evil doppelgangers on the site, which in Nissan's case, we actually called his good doppelganger because Nissan's the evil one. It's Nissan, who built a lot of the architecture for this stuff. And it's actually pretty funny who you come up with. Actually, I think you wanted to murder your person, didn't you? He's saying no and then shifting his eyes, so I don't really quite know. So there's a lot of stuff you can do with this, and it's running at full production scale. So that's basically it. So yeah, come bug me after the talk or over a beer. If you want to follow me on Twitter, go ahead. Add me on LinkedIn or email me. I'm always happy to chat this stuff. Questions? Everything.
So I would gather Google has built something like a topic map of the internet. So they get to know our profile through our history searches. So if I search for Ruby under my account, I get rubyland.org as the first hit. My wife gets a jewelry store or something.
Yeah.
She's using her account. What's to stop Google from going into this business?
Nothing. I don't know. I mean, Google doesn't really seem interested in the online dating market.
No, it's not a fit. But technologically, it seems to me they could do it right away if they wanted to.
Yeah, but I could say the same as with Facebook, but they seem to have not done it. And they were trying to do it. So I think it's a question of, a lot of people think of that as a search problem, and this is actually more appropriately a clustering problem.
Yeah.
And as soon as you spin it around that way, it becomes a lot more obvious to do this. But if you're thinking about it in terms of search and query, which like people at Facebook and Google do a lot, then you kind of get trapped in a different set of algorithms and honestly, I don't know. I don't work there, so maybe they are doing this and they haven't told me. I don't know.
Does your algorithm work equally well for homosexual men and homosexual women?
The honest answer to that is I don't know because I haven't yet tried. Well, there's nothing specific in this thing that I've specified heterosexual or homosexual. What I will say is that like our site is going to be obviously more percentage-wise heterosexual, just because we're kind of everything to everyone site. There's no specific demographic we're going for, and just population-wise, they're more. So the model itself will probably be tilted more towards those interests. That said, since I'm not specifying gender here, there's no reason why it couldn't. If I saw that there was a market difference, there's nothing preventing me from building a model specific to a demographic like that. right? It just requires me to change a few lines of code. So I say, when I'm grabbing users, instead of saying, where you're searching for opposite gender, I say where you're searching for the same gender, and that's my initial pull, and it creates the model. So, yeah, I just don't know yet.
So, I imagine while you're doing this, you're scheming and coming up with crazy business ideas for things you can apply this to. Some of those you tossed out.
Yeah, I don't really want to say those. Because I kind of just told you some of how to do this, and yeah. If people want to know that, feel free to talk to me after when I'm not being recorded on video.
Is there any plan by Plenty of Fish to license this? Or are they just keeping it internal?
So the question there was, is there any plan to license it? I don't know if there's a plan to go live with this yet. Obviously, I think we should go live with this. It's an internal debate right now, so the honest answer is I don't know.
So on other dating sites, like OkCupid has their blog they release a lot of data on, right? And for them, they've kind of shown that pretty famously that a lot of times people's preferences don't actually match up with what they're looking for in a match kind of thing. So I mean, I realize this is only like a search problem, or like you said, a clustering problem right now, but is there a way you could envision to kind of make it a more meaningful match for people as opposed to just like, matching interests? So
absolutely. So right now we don't have a lot of data because this thing isn't being used with like how people are performing in terms of matching on this. So if this were to go live and I had data on that, I could certainly, for example, I might discover that like, this topic and this topic, even though they line up, actually aren't good for matching from men to women or something like that. And I could build an algorithm around something like that.
So for now, it's just like a data problem of actually getting that, successful match kind of feedback or whatever?
It's also a question of how you want to do it. So like one thing we've talked about, so we have other matching algorithms that are actually live on the site right now. There's no reason why you couldn't take, for example, the score from this algorithm and use it as a weighting or attribute in another matching algorithm. So you're kind of balancing all of those things. That's definitely a possibility. So it's really kind of just limited to, I guess, the idea and how you want to use it. So we've talked about doing exactly those things.
I guess is it possible to expand on that a bit, or is that like trade secret stuff?
No, it's not so much that it's trade secret as much as it's more of a sort of like, I guess, business type decision. In terms of actually like improving it in like, for a classifier, good match, bad match, that I need data on. But, given data, I know how to build a classifier. So, I can iterate from there. The tricky thing though with that is going to be like when you load it, like when you update the model and you load a new model, now all the topics are different.
Right.
So, I'm not quite like, I guess what I could do is I could take the old data, put the new model, like build it on the new model, see what matches on that, and learn the weights in SVM or neural net or whatever off that, and then use that as the new matching algorithm. So that's definitely a possibility.
I have a question. So how do you know if it's a good match?
Yeah, so that's basically what he was asking. So right now you don't. So here the good match is...
I mean, like, with the current algorithms, for example, you have some current algorithm, right? Like, two people start to go, so basically, how do you know that this was a good match, this algorithm worked? How do you measure that?
Do you have a good current algorithm?
No, how do you measure which is good?
Okay, so there's a bunch of questions in there which I'm not sure I understood. I think I can answer all of them, but let's make sure I understood them. So was your question specific to this algorithm or just in general?
Just in general.
Okay, so for that, what we have is we have data on people that have actually left the site together, like in a couple. So that's good couple, bad couple, and things like that. So there, we do actually build up a data set that's not perfect because not everyone says they left the site together. A lot of it we infer. So if you see two people talking on the site and then they both delete their profiles, within a certain window, you kind of infer that they left the site together. But it's tricky because a lot of people go inactive but don't delete their profile, and like, do you count that? Do you not? So that's a whole other bag of worms, which we actually do, and we're constantly actually building out that set. We've also talked about trying to not just build a successful couple, but like you win on a date set. That's really hard because you have to like try to infer it from the messaging data and so on. And it's a really hard problem. I've actually worked on it and was getting so many false positives that I kind of hit a wall, stopped, and was like, I'm going to come back to this later.
So can you just use the same information that you were talking about previous data, and run the topic model or a new model on that and like see?
Yeah, the set's too sparse for that. A lot of people, because we don't have a lot of calls to action. Oh, so she asked, sorry, I'm repeating the question. So she asked, why can't I take the data from that set? There's no call to action, run this op-ed and try to build it. The problem is a lot of that data is older. Not everyone put in their interest, so the set is too sparse. Also because we were never call to action or highlighting anything around interests. It's just way too noisy there. So, for example, some of the people that match up well under interests in that set might not have ever even seen each other on the site. Because if they were never in any of the other matching algorithms, then like saying like, well, this person was a perfect match, but in the 3 months they were on the site, they never even saw that other person's profile, doesn't give a good learning there. So this thing would have to sort of go live in some way to start building up data for it, for me to build the kind of thing, which I want to do. And we did try to do what you're talking about, it just was way too noisy.
An earlier question from someone different asked about generating new topic models from time to time.
Yep.
And your answer seemed to suggest that you did it from scratch. That when you regenerate a topic model, you start from scratch. First of all, am I right in inferring that?
I do. Your next question is going to be, can I just add to it?
Or not necessarily,
or like do online
can you learn from it so that you're using data from past topic models?
Yeah. So the answer to that is yes. That is a damn good idea. I should probably try that. I have not yet.
Thank you.
Follow-up question to that. So with Gibbs sampling, you said that you might get this slightly different distribution out.
Yeah.
How stable is that? How different will you get between runs?
Between runs on a person or building the model out?
Building the model.
That's relatively stable. I mean, things will move around, like topic 1 won't be topic 1.
Yeah.
But like snowboarding and skiing are going to go together almost all the time. So that's relatively stable. And even when I like eyeball it, I'm like, that doesn't look kind of similar. When I then actually try to run matches off it, I get the same people. Yeah. In a set of 50, I get like 47 of the same people. So it's like, yeah, it's kind of doing it differently, but it's getting the same thing anyway.
When you pick the number of models, I guess that's a tricky issue. And when you see model number 30 has all this vocabulary, you might feel like, oh, should I split this one, right? It might make more sense to split this, but not the others. So your correlated topic models that you want to go back into might be an opportunity, I guess that's the question, to build way more topics and then see which ones you can combine.
Yeah, so that relates to, I forget who it was, but someone in the back asked a very similar question. So correlated or hierarchical would be kinds of examples of that. So like even like hierarchical would be splitting, topic 1, which is outdoor sports, I'm going to split down the chain. Both of those are sort of were sort of like next kind of things to try if this wasn't working well. That's more a question of like, at some point you have to stop because I had other things to do. If this is like picked up again and we make a serious push on this, then that's probably next on my list to look at. So it's not that this is inherently better, it's just, I spent 6 months and I had to do something else at that point.
You're saying better, but I'm not sure if you're not measuring accuracy. When you say better, what do you mean?
Well, so he's saying, we're saying better, but because I'm not measuring the accuracy, what do I mean? So this is the standard problem in unsupervised learning, right? There is no great measure. It's even harder for topic models, so there's actually an entire literature around measuring whether or not one topic model is better than the other. And as far as I can tell after reading a bunch of papers, the answer is and usually what happens is someone comes up with a really great statistical measure, and I should caution I'm not an expert in like predicting accuracy of topic models, so I could be getting some things wrong. But from what I can ascertain, someone comes up with a really good statistical measure, and then they show it to human beings, and they're like, no, that's a horrible model. And then someone shows human beings and like, yep, that's a good model, these are good matches or good topics. So this is very often used, for example, to categorize articles like in a corpus of things. So, you know, you're looking at every science, like article in the journal Science, but they're all really different topics. Some are like genetics, some are physics, some are like specific types of genetics and physics, and so on. And then they're like, some human being comes up with like, they're like, this model's really good, and like, no one can come up with a measure that makes that one higher. So in this case, it was kind of a lot of shopping around to people, because it's not live. I shopped it around to people around the office, and I said, well, here's a set of 50 matches, here's a set of 50, here's a set of 50, you know, here's 10 different models. Which one do you like better?
And did you send them on dates with those people that they chose?
Martin, did you go on any dates?
It works well.
It works well. So to give you a description of how well it worked for Martin, I don't know if you went on any dates, but when we were building out a live page as part of a hackathon, Martin is one of our .NET and web developers, now a DataOps guy. He was building the front end for this. And as soon as it kind of started working, his productivity fell off because he kept just clicking over his profiles. So then I kind of was like I was like, yeah, it's really great, but we need this done in like an hour, so stop clicking. So if it were to go fully live, I would probably split test. And I would just see like, you know, everyone is coming to page A and page B if they're two different models. You know, of the 50 profiles, I show you how many are you opening up, how many are you sending messages to, how many of those are getting replies, which one do we care about more or less, weigh it, and then make a call. And I would just keep iterating on that. Because at some point you have to let the users actually dictate. But since it's not live, I kind of just guess. But I mean, if you actually have a spreadsheet of like a bunch of different models and words and things like that, and there's like probably like 35 tabs at this point, where it's like, this approximation scheme, this many topics, so on, all the way down.
Did you include private messages between users in the input?
No, it's just a profile data.
Just profile data.
Just profile data.
Could you? Would you?
For something like this, probably not. Because, for example, I did try to actually include people's real, like actual profiles, not just their interests. And that was a lot noisier because people are way more nonsensical when they're writing full sentences as opposed to listing things they like. That said, there are models sitting on my computer of profile data. For other things, like for messaging, yeah, there's a lot of stuff you could do with messaging or things for categorizing and modeling that. I don't know if I would try to do it for matching. Also, the computational cost, considering we're getting like 20,000 messages a minute, is kind of tricky.
My next question is inspired by the earlier question about preferences being inconsistent with actions. Some social networking matching sites suffer from the problem of people lying about their preferences or lying about themselves in order to get a better match. And I'm wondering if you have developed any way to detect lying. No.
No. Outside of the fact that there's a really large spike of men who say they're exactly 6 feet tall, and a really large spike of women who are exactly 29 years old. Yeah. So like that kind of thing you can do, but not around like. I mean, if somebody says they're interested in baseball, I don't really have an easy way to say like, well, that person doesn't really like baseball, right?
How large is a typical topic? How many words? And are those words treated equally, or?
Okay, so the question is, how large was the topic, and are the words treated equally? The entire vocabulary is in every topic. And what you basically have is a probability distribution over the vocabulary in the topic. So each one is probably 200,000 to 300,000 words, depending on the run and the model. No, because it's a probability distribution over it. So like the ones that I showed you, that was like, you know, snowboarding, skiing, the words like long walks on the beach is in that topic. It's just, you know, 170,000 down compared to the other words in that topic, so it's like 0.000. 10 to the minus something % likely to occur in that topic. So, you can actually graph like the distribution of probability over a given topic among the vocabulary, and it's, some curve. It goes like this. And it's not ranking, so the first the first word in topic 1 and the first word in topic 2 might not have the same like actual probability rank. Topic 1 can be super stratified and topic 2 could not be. So it's not that like the first word is more important than every one.
That's actually interesting. I was curious whether the shapes, the distributions of the topics are very different or somewhat similar.
That's a good question. I haven't done it in a tremendous amount of detail, so I can't answer it right now. But it's a good question. Like, I can definitely look at it. Yeah.
I'd be curious if there was something that like stood out in the shape of the.
So now it kind of makes me wonder if things like the super nerdy topics are more stratified. Probably the super nerdy topics in guns would be my guess. People that are into guns and quadding are really into guns and quadding, and not a lot else. Maybe, yeah. Also archery. Apparently that's coming back thanks to the Hunger Games.
Was there a chance of the data itself being published?
I didn't hear you, so.
Do you think there's any chance, if this goes live, of the data itself being published?
The full data, probably not. That's going to probably go under trade secret, and I'd have to make a compelling business case for why we should do it. So I come from academia, so I kind of want to just throw everything out there because that's sort of my background. That said, that doesn't really always work in business, so that's not really a decision for me to make. We have written a couple sort of funnish research-style blog posts that have been, some articles have been written about that, without really mentioning it, have used some of this stuff. So I think we did one on like what states are the most romantic in the U.S. And that actually used this. So we actually looked at which ones had the most lift in the romantic categories, and that's how that map was made. We've talked about doing other ones as well, but because it's not live, we haven't mentioned it explicitly yet.
Are you guys thinking about possibly using this for your ads platform for targeting ads?
So the question is, have we thought about using that in our ads platform? That idea has been pointed out by me and some other people. I do not know. The marketing people also seem quite excited about that, but again, it's a business decision, so I don't know. But absolutely, you could use this in an ads platform.
I kind of lost the here it comes back. The subcultures. I'm still thinking about the 30 topics only. How do you pick the number of topics? So you showed us I think it was Kawasaki Ninja.
Yeah.
So how well can you detect subcultures? It might not be a business case.
Yeah, so that goes back to, I think I mentioned it earlier on, where the more topics you do, the sort of the finer the sieve is. So there's a lot of sort of ideas I've had around that. So there's no reason why I can't have more than one model live. And for a while, actually, in testing, I had a 10, 30, and 50 all at once. And I was either trying to combine them in various ways, or I was envisioning different pages where it's if you want a broad match, I can give you this. If you are in a subculture, I can give you this, and so on. So there's absolutely nothing preventing that. 30 is what I'm currently using right now because that seemed to make the most people happy when I showed it. But that's in no way fixed. I mean, it's one parameter that I have to change in my code, and that's it. So there's absolutely no reason why I couldn't do those things. It's really then comes down to a question of use case. So do you want this thing to be a broad thing that most people on the site can use? Then you can't go too high in the number of topics, right? Because most people who are on a dating site that say they like motorcycles are probably not. Well, okay, maybe motorcycles is a bad idea. Martin's looking at me. But are probably not going to be in the I'm only going to date a girl who likes this type of motorcycle and nothing else, right? But some people might do that. So, maybe one thing you could do is have like the broad thing, and then you could have a secondary page. It's like, if you want to get really specific, here's an option. Another thing you can do, which is not quite full hierarchical, but is more kind of ad hoc or doing it by hand, is once we have some data, we can look at like sort of the most popular topics. So like, let's say like, nerdy TV show tons of people are in that. Maybe I'll stratify just that topic, right? That's an option as well. So I can just take people that have a lift high in that topic and break down by that. And then it becomes a question of, do I want to do something like a hierarchical or correlated model where it's automatic, or do I want to just drill down to the one or two topics that people really seem to care about? I don't know. Without actually doing it, I don't know. Keep in mind, I'm currently the only person doing this, so there's only so much that I can do.
Good question from the audience. Who's the first honor for any of these meetups? Alright, there's many more, so it's back. The second one is, who was at the talk that Elena gave earlier sometime last fall, where Kazan gave a talk on LDA, public content, but CPL.
Oh.
Yeah, keep going.
Okay. I was waiting for your like.
No, I was just curious.
Any other questions?
Actually, one more. It's not a question. We need more speakers. So if you're interested, or anything, giving a lightning talk or the full deal, talk to anyone over here. Or salad.
They'll buy you a beer.
Yes, or salad.
And one this. How long does it take to do like a full, complete run of this, and what were the specs of the machine or machines you used?
So did everyone hear that, or do you need me to repeat? Because it's a good question. So the question there was, how long does it take to build this thing out, do a full run, and what were the specs of the machine? So this breaks down into 3 separate stages. The first one is building a model. The second one is taking a new model and running it on the user base in whole. And then the remaining step is like keeping it live. So I'll answer them in stages. Building a new model out takes roughly, depending on all your thresholds and stuff like that. So for example, if I raise the threshold on TF-IDF, then there's less words in the vocabulary, so it takes less time. The more topics that I want, the more time it takes because it has to chain through the Monte Carlo longer. Or it's not that it has to chain through longer, just it takes longer to converge because it kind of wobbles around between topics that are close together. Roughly 3 to 5 hours to build a new model out from scratch, and that's on about 4 to 5 million people. To do on the full user base, I'm doing a map reduce. So that takes, I think it's like 3 to 6 hours off the top of my head, somewhere in that ballpark, depending again on the model and how complicated it was and so on. Once the model is actually caught up and live, then it's updating less than 5 seconds on every run. So if you change your profile and there's not something wrong with the site or the server, then within less than 10 seconds or less than 5 seconds, you'll have new matches. I actually built out the full search functionality this morning. So I only tested it on myself, which is not really fair, but on myself it was returning in milliseconds. So I searched and I was getting results in, I think, less than a second. But it's not going to scale at that rate. The specs of the machine, I don't know what the SQL side is. The R box that I'm running right now is, it's a Linux box. It's 24 cores and a 1/4 terabyte of RAM. So it's not small, but it's also like a $10,000 or $15,000 box, which is not bad at that scale. And that's running on full production. Give me more boxes or more cores, it will get faster to do the first 2 steps, because a lot of that is parallelized. So especially the building up on the completely new user base, that's fully parallelized on the cluster. So more cores just means faster.
I might have just mentioned this, but on that input data set 5 million, how big is the model output?
It's about a gig.
1 gig?
Yeah.
Yeah.
It's about a gig. So what I do to keep it updating quickly, so for every time I wanted to run a user, I like reloaded the model. So what I do is I load the model, I cache it, and then it basically loops with the model in memory. And that's how I got it to. I got it down from minutes to seconds again. Keep in mind that I am not a production developer, so this probably can be pushed a lot faster than I've pushed it, but this is as fast as I've gotten it at this point. So don't take those limits as like hard limits. These are hard limits for a data scientist that doesn't know how to optimize stuff in production.
Any other questions?
Who's my favorite?
Go ahead.
Great, thank you, Tommy. So just to let people know, we're heading to Mr. Brownstone's afterwards. Hootsuite's always been very generous with their venue, and there are Hootsuite employees such as Andrew, who stay late and make sure the venue is open for us, and I'd like them to not stay late. So if we could vacate the place in 15 minutes, that'd be great. If you do want to talk, like I said, there's a venue in Mr. Brownstone's on May 13th, we'll be there. If we see you there, we'll see you maybe July 23rd for Tawfiq's talk. Anyways, see you next time.
First row people, keep your chairs there. For the second row people, can you stack them just by those tables over there? 3 high. Yeah, 3 high.